this last video is on rotations. It's our last rigid transformation, meaning the size and the shape doesn't change, but the shape is being moved. So when you're doing a rotation, you're doing exactly what rotation means, which is turning or turn. And again, I like to use these like little wheels, turn this way or turn this way around a center. So you always will have a center. Most of the time for us, the center will be the origin, which is 0, 0. But as you can just see, like, this shape is turning. And there are specific rules. You could use your pen to kind of show, like, oh, how is this changing? Oh, this point is now here. Like, oh, that's how I rotate it. But it's really important to know these rules, because these rules will kind of help you check your rotation. So you always rotate in degrees. You have 90 degrees, 180 degrees, 270 degrees. You can rotate clockwise or counterclockwise. Most of the time you'll see clockwise, but you know, you want to be prepared for any situation. So again, you know your original is always X, Y. So when I give you these new rules, these rules are what you do to your X and what you do to your Y to get your new point. So if I'm doing 90 degrees clockwise, whatever my original, so I'm going to write right here, my original is always X, Y. So if I'm rotating my original X, Y 90 degrees, my Y value becomes my X value. So you put your Y value first, and then you flip the sign of your X value. So if it's positive, it's now negative. If it's negative, it's now positive. So that's what we mean when we put these negative signs there. It just means flip the sign. It doesn't mean, oh, it's negative. If it's positive, it's negative. If it's negative, it becomes positive. So just be really clear about that. And this rule is actually also the same for 270 degrees counterclockwise. So if you can start memorizing, like, oh, these are the same for this one, it'll really make the process easier. So 180 degrees is the same straight across. So I'll go ahead and show you that. Those are always the same, no matter if it's clockwise or counterclockwise. You just change the sign of X and Y. So your X and Y stay in this position, but you change the sign. So those two, always the same. And I'm going to color coordinate these for you to make sure it makes sense. And then lastly, 90 degrees counterclockwise is the same as 270 degrees clockwise. So you have here, your Y becomes your X, and it also changes its sign, and your X becomes your Y. Okay? So again, this makes more sense as you do it, but I want to just kind of highlight the ones that are the same. Those two are the same. And again, feel free to use any coloring utensils you have or borrow some from me. It's all good. These two are the same. Again, this is just going to help you in the long run to memorize like which ones are the same. So you're not memorizing 1,000 different ones. They're actually just the same. And so just remember, like, 180 degrees is always the same straight across. And then 90 degrees and 270 degrees, they're always paired for clockwise and counterclockwise. So it's just one way to memorize it. Another way to help you with rotations is to recognize how many quadrants it moves. So I'm going to add that here. So how many quadrants does it move? So quadrant moves. So if you're moving 90 degrees, your shape should only move one quadrant. If you're moving 180 degrees, your shape should move 2 quadrants. And then as you can probably guess, if it's 270 degrees, it moves 3 quadrants. So again, just ways for you to easily check your work as you want to look back at it. So we're just going to practice this because, again, practice makes perfect. A lot of this stuff doesn't make sense until you do it. So we're going to practice rotating 180 degrees about the origin. So 180 degrees is what we're rotating, and the origin is actually our center, and so therefore it is 0, 0. Okay? So this is what we're rotating around. That's our center of rotation. And I'll actually make that red. So it's not our actual point of our shape, but it's just what we rotate around. And so because we're doing 180 degrees, we want to write our rule. So our rule for 180 degrees here And notice it doesn't say clockwise or counterclockwise because it's the same no matter what. So you just, I put a percent sign. This should just be a degree sign, just a dot there. But that's why they didn't put clockwise or counterclockwise, because it should be the same no matter which way. So I just like to write my rule first because I don't want to think about that later. So it's negative x, negative y, which just means change the sign. The x and y stays in their places, but you just flip the sign. So we first need to write our original point. So if I'm looking, u is negative 4, 0. W is negative 4, negative 3. X, negative 3, negative 2. And as I said before, everything is staying in the same place, but the sign is changing. So your x's are all negative here. So a negative times a negative will be a positive, so they become a positive. Here, 0 is neither negative or positive, so it just stays the same. And then here, negative 3, that's negative, flip the sign, that means it's positive. Negative 2, this makes more sense, negative times a negative is a positive, it becomes a positive. So again, just flipping those signs. And then of course we want to always come back and plot our new points. So we have over 4 of 0, so this is going to actually be u prime. Then we have over 4 of 3, and that's going to be w prime. And then we have over 3 up 2, okay. And that's going to be x prime. And then of course you want to make sure that you connect them. So connect, 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 and you see you have the same shape, but the points have been turned. And notice again, how many quadrants? 2 quadrants, so it's already moved twice. It's moved this way, okay? And so you can take your u and you can flip it once, flip it twice, boom, u is where it's supposed to be, x, flip it once, so x is this way, now it's this way, now it's that way. So you can use your pencil to check as well, but this is a guarantee fix and use your rules. Alright, you can practice on your own by pausing it and then checking, or you can just stick with me and we can do it together. So, 90 degrees clockwise. Okay, about the origin. So we know our center is 0, 0 as it's going to be. And we know 90 degrees clockwise is going to be our rule y, negative x. Okay. So we want to just write our original points first. Okay. And now first thing we need to do is realize the y's come first. So I'm going to color coordinate that for you. The y's come first. Y's come first now. So color that I haven't used is this color here. And so your y, whatever your y value is, it now is moving to the forefront. So you're not changing the signs, you're just changing the position. So you can just start by writing all your y's first. But then your x values go here, but you're changing the sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. So you have negative 4. A negative times a negative is a positive. Negative 5, a negative times a negative is a positive. Negative times negative is a positive. Okay? So again, you're flipping the signs. And just to show you what I meant about this, this is now in the front. Okay? All of that is in the front. And now we're just going to plot these on our graph. So we have negative 3, positive 4. Okay. And that is I prime. then -3, -5, or -3, +5. Okay, so this is that, and this is going to be L prime. And then we have -1, 5, which is going to be M prime. Okay, so just connect those, and you see our triangle has turned. Okay, so again, it moved one quadrant, M has turned, L has turned, every point has turned, okay, because we moved clockwise, which is just this way. That's the way we went around our center. And then go ahead and practice one at 80 degrees. We've already done this one. Remember, it says clockwise, but that just means it's the same as counterclockwise. 2 and then to the origin. Go ahead and do this, and then when you pause it, you'll see. Alright, so this is where you check your work. So we're moving 180 degrees clockwise, which just means we're flipping the signs of all our points. So if the point is the x value was positive, it becomes negative, y value was negative, becomes positive, so on and so forth. So roll all our points, and we just change the sign. So notice here 2 and -1 is now -2, +1. 0 is neither positive or negative, so it's always 0, but -3 becomes +3. -3 and -2, both negative, both become positive. And so when we flip this, we notice each point has moved 2 quadrants. So look at E, it's moved 1, 2 quadrants. G is on this line here, so it just moved 2 axis lines, so boom, boom. And then V moved twice. So again, using just the rules and the basics of what you should be observing will help you kind of determine if you're in the right place, but your rule is always going to make it concrete. So you can do the whole pencil method, you can do like what quadrant's supposed to be in, but the rule will give you the exact point. So it's just really important that you focus on that. At this point, this can actually get stapled and glued into your notebook on your rigid transformation page, just like